let's start with a few basic things. We're going to talk about straight lines. So first thing I want to set up is I want to draw you a straight line and kind of explain how that works. So when you're dealing with a straight line, you have some things that are true all the time. This side of the straight line is 180 degrees. You got 180 degrees in that side of the line. And the way that you might recognize that is when you're dealing with a right angle. Okay? When we have a right angle, we know that that's 90 degrees. And we know that that is 90 degrees. So together, we have 180 degrees. Okay? So every straight line is 180 degrees. Alright. Now we have some different things about lines. We have a perpendicular line, which means that line AB is bisected. Bisected means to intersect with a line or cut across a line with line CD. And when it bisects it at an angle that's a perfect 90 degrees every time. Now you notice every time I draw one of these little boxes, that's a representation of 90 degrees. Okay, we got some other things. So once again, we got a straight line. You don't always have a perpendicular line that intersects a line. You can also have a parallel line. When you have a parallel line, that means that there's no point anywhere that line AB and line BC intersect. For instance, a lot of lines, you'll have AB, and you'll have CD. Well, they'll intersect at some point. But parallel lines, they never intersect. Okay, so we're back to our original line. Now, every line that is bisected is not bisected at 90 degrees, or it is not bisected by a perpendicular line. Sometimes you have a line that intersects at an angle such as this. Okay? So let's just say that this angle right here is 40 degrees. Okay? Well, we know that this straight line AB has to equal 180 degrees, right? We know that from here to here has to be 180. So that means from here to here has to make up the difference of that 180. So you're going to take 180 minus 40, and that lets you know that this remaining angle is 140. So you have a total of 180 degrees there. Now, something else you need to recognize is that CD is also a line. Okay? So, if we were to rotate, or we were to look at CD, or rotate your iPad sideways, and we put line CD straight across like this, and we had
Ladies and gentlemen, as you boarded the aircraft.
And then we had so if we had the lines look like this, where this was A, B, right? And if you remember, right here was 40 degrees. And the way we can verify that is we have A to this center point. We'll call this center point O. We'll call this center point O. So A to O to C was 40 degrees. And down here, A to O to C is 40 degrees. And then we'll continue on with that being 140 degrees. And as we stated before, the total is 180. Okay, but now let's look at this line CD. If from C to O to B is 140, and we know that this straight line is a total of 180 degrees, right? That's going to be another total of 180 degrees. That means that this also has to be 40. Okay? If we look at the opposite side of this, we know that this, no, what did I do? What did I do? There we go. Okay, we know that this has to be 180. Therefore, this 40 plus whatever this is has to be 180, so that's going to be 140. Now I want you to notice something special about those relationships. Let's go ahead and redraw this a little bit cleaner. Okay, so this is 140, this is 140, this is 40, this is 40. Now, if you're dealing with a straight line, whenever you have a bisector, this angle right here and this angle always going to be the same. These are called alternate interior angles. Just like this angle and this angle are always going to be the same. Those are alternate interior angles. That's always going to be the case. Okay? The reason why I show you this is for this next part. So, say we have a parallel set of lines. So these never intersect. So that's A, that's B, that's C, and that's D with a bisector. We call this B and F. Okay? So we're going to look at this top set, AB, and its intersection with EF. And we'll just call this point O. We'll call this point P. Well, let's go back to whatever numbers, I don't care. Let's say that this is 30 degrees. Okay, so based off of the rules we just said, if that's 30, then that has to be 30, right? If this is 30, then that means this needs to be 150 to get you to 180. That means this also has to be 150. So we understand that line. But when you have parallel lines, this EF is going to bisect AD and CD at the same exact angle. The same exact angle. So that means where EF intersects AB, this point right here is going to be the same as this point here. So that's going to be 150 as well. And if this is 150, this has to be 30. And this has to be 150. And this has to be 30. But you'll also notice some more things. Okay? This point right here and this point right here, they're also going to add to 180. This point right here and this point right here, those angles are also going to add to 180. Whenever you have some angle plus some angle that equals 180, those are called supplementary angles. Alright, so you're looking at this like, why the heck is this important when we're talking about parallelograms? Well, all a parallelogram is a set of two sets of parallel lines. So let's say that you have AB and CD that intersect with two parallel bisectors. So this is EF and that is GH. Okay, so let's say that this is 60 degrees. If this is 60 degrees, that means this has to be, oh no, what the heck is going on there? If that's 60 degrees, that means that has to be 120. Okay, well, these are parallel lines, so this is 120. These two need to add up to 180 as well, right? So that means that's going to be 60, and that's going to be 120. This and this are alternate interior angles, so that's 60, right? And this line is not very good. Let me fix this line. It should be a better angle.
Ladies and gentlemen, due to weight imbalance, I'm going to ask for 6 volunteers to come off the plane. If you volunteer to come off the plane, I will give you a $300 Delta credit card. So, first come, first serve. So I'm going to need 6 passengers to volunteer, please.
So, as you notice, if there's 60 right here, once again, we get 120 right there. And if this is 120, then this will be 60. Now let's take a second to identify some other relationships. This angle right here and this angle right here, they're opposites, but they're also they're on the outside. So when I said yeah, so they're opposite and on the outside. So those are alternative exterior angles, right? So this is an outside angle to this whole shape, and this is an outside angle, and they're opposite when we're talking about this bisector and these parallel lines. So those are always going to be congruent as well. So now we can continue to label these lines. So if this one right here is 60, this is 120. And that's the same as this and this are the same because they're alternate angles. Then we have another alternate angle here, which is 60, but you know, you can fill all of this stuff in. So as you see, there's some specific relationships going on here, and it makes it easy to fill out all of these angles. Now, if we look, we have a parallelogram here in the middle. And all a parallelogram is shapes that are made out of two parallel sets of lines. So what do you notice about this parallelogram? Well, first thing is that this angle is the same as this angle. These opposite angles are exactly the same. This angle is the same as this angle. Opposite angles are exactly the same, right? Okay, so that's one thing you notice about it. We notice that any two sides, so this, well, not any two sides, but any two sides that are next to each other, so 60 and 20, that's going to equal up to 180. 120 and 60 equals up to 180. We got 120 and 60, 180. So any two sides that are next to each other are going to equal up to that 180 degrees. Let's give us a new shape to deal with. It's a little bit cleaner. So what do we say? This is 60. Nope. It's too small. That's 60, 120, 120. Okay, so that's one thing that comes up. Now if we think about diagonal bisectors, say we put a line that cuts across there. We'll make two triangles, right? And any triangle has 180 degrees in it. We can double check that because well, I guess we can't really double check this so easy with what I was about to do. But every triangle has 180 degrees in it. And we know we bisect this, right? Whatever this is, we look at the rules, look at all the rules we talked about. Right? Let's say that this continued on. This continued on. You got another line there, right? So even though that thing was 120, whatever this is going to be the same as whatever that is. Whatever this is going to be the same as whatever that is. Because that's just the way that thing works, right? Alright, I'll give you that to marinate on and see if that's something that works for you, if you need something else for that beginning part.